This is chapter 10, number 75. And the question goes, a building is located on the equator of the Earth. It rotates. A person on the top will have a greater tangential velocity than a person on the ground. If an object is dropped from the top floor to the Earth, it lands east of the point vertically below where it was dropped. The first question tells us to derive the equation to find the distance that the object traveled to the east. The second one says to solve for the distance if the height of the building was 50 meters. The Earth is this circle with the radius of little r and an omega, which is found which is equal to 2.27 times 10 to the negative 5 radians per second. Velocity of the top, the velocity of the bottom. Notice that the velocity at the top is greater than the velocity at the bottom, and right here is the delta H of the building. The velocity in the x direction, it could be found using velocity of the top minus velocity of the bottom. The velocity of the top is omega times the radius of the Earth plus the height, while the velocity of the bottom is found with omega times the radius of the Earth. As you can see right here, omega r and omega r cancel out, and you're left with omega h. The distance traveled is represented by delta x and is equal to Vx times t, whereas previously stated Vx is equal to omega times h. T is found using kinematics on the stone or the object that was dropped. And negative h, it's negative because the object is going down, and the acceleration is negative g, negative because again it's going down. And when you solve for t, you're left with the square root of 2h over g is equal to t. So, to find the distance that the stone travels is equal to omega times h times the square root of 2h over g, which is simplified, is equal to omega times the square root of 2h cubed over g. If h equals 50 meters, omega will still be a constant as well as g. Omega will be 7.27 times 10 to the negative 5. That is found using the 2 pi over 24 hours is equal to omega. And by just substituting the numbers to the previously explained equation, you get 7.27 times 10 to the negative 5 times the square root of 2 times 50 cubed over 9.8, which you're left with 0.0116 meters, which is pretty small, so it is why we ignore it in most projectile problems.